Continuing on with our lessons on quadratic functions and equations, this is lesson number 2. We've been looking at quadratic functions and quadratic equations, and as you know, if we're looking at a quadratic function, it takes the form f of x is equal to ax squared plus bx plus c. And there's some limitations on each of these variables where a, b, and c are all elements of real numbers, and a can't equal 0. When we write that as an equation, it's y is equal to ax squared plus bx plus c. And again, it follows those same restrictions where a, b, and c are elements of real numbers and a can't equal 0. Now, when we're looking at the quadratic equation, we have it in that general form where ax squared plus bx plus c is equal to 0. And this is the one you've been looking at for the past few units. And we found that the roots and the zeros are all related to each other. And so is the x-intercept. Now, when we look at the general form, which is what we've been looking at this whole time, we also are going to take a look and examine the standard form of the equation. And the standard form is written as ax minus p plus q of f of x, or y is equal to a times x minus p squared plus q. All right, so let's just jump into this. We're going to be looking at more examples of how to graph these types of equations and functions and what exactly they look like on a graph. Let's look at this first example where we're analyzing the graph of the function with equation y is equal to x squared. The first thing I'm going to do is graph the function with this equation y is equal to x squared. All right, so you have to bust out your graphing calculator and using these same window settings. So what I'm going to do is I've already preset these window settings, but I have a x min of -6. Because if I look on this graph, it doesn't go past 5, so I just said it's -5, or sorry, -6 and positive 6. My scale is going to remain the same, just a scale of 1, but my y min and my y max values I set at -1 and 11. Because I know if I graph x squared, that it's not going to go past those points. So when we graph an equation y equal x squared, the graph of this function, this shape that it takes, is called a parabola. Okay, so this is called a parabola. Now this is a really interesting shape because it exists in so many different places. But we're just going to examine what it's, just some of the relationships that you'll find with quadratic equations and this parabola that their graphs take. Now the first thing we need to do is fill in this table. We can do this in a very convenient way. As you know, if we use our graphing calculator, I'm going to press second function, and then I'm going to press the graph button, and if you see the second function, it's the table setting. And I want to know what values of y are related to my values of x for each of these points. -3, -2, 1, 0, 1, 2, and 3. And so starting at -3, I have a y value of 9. And as I go up, I go 9, 4, 1, 0, 1, 4, 9. 1, 0, 1, 4, 9. Okay? Now, the next thing we need to do is think about these questions here. We know what our graph is going to look like, what our parabola looks like, and eventually we're going to have to record what it looks like on this graphing paper here. And so we know that for every value of 0 or of x, that's going to correspond to a value of y on our graphs. So as I go up to 1, I move up to -1 and +1. As I move forward to 2, I'm going to go up to +4 on my y. And then 3, I'm going to move up to 10. Or sorry, 9, not 10. And the next thing we do is just connect these points. And there you have a parabola. Okay, so the axis of symmetry now is the mirror line which splits the parabola in half. So in this case, our axis of symmetry would be right here. So if we take this and we were to cut that in half, we would have both halves of a parabola, essentially. And so that's our axis of symmetry, and in this case, our axis of symmetry is equal to x equal to 0. Okay, so basically, whenever you have a parabola that's moved across your y-axis, the point where you can split that parabola in half and you have two equal sides, that is known as the axis of symmetry. The next thing we're going to look at is the vertex of the parabola, and this is where the axis of symmetry intersects, and that point creates a minimum point or a maximum point. Now, it's a minimum or maximum depending on whether your parabola opens up or down. So in this case, it'd be a minimum point because our parabola is opening upwards. See, it's pointing up. And the lowest point or the minimum point on that parabola is at 0. So here, if we were to label the vertex on this graph, we'd say that V and the coordinates are 0 and 0. Okay, so the maximum or minimum value of a quadratic function will occur at the vertex, and it's represented by the y coordinate of the vertex. So then we need to complete this fill in the blank statement. The minimum value of the function with equation y equals x squared is 0. And I need to move down there. So that means that the lowest point on our graph is going to be 0 on our graph of f of x is equal to x squared. Now we need to state the domain and the range of this function that we just graphed. So if we look at the domain, our domain of x is, if you look at what this graph is actually saying, it's saying that this is continuous. This graph can go on to infinity. So we don't actually know where it stops, which means that we say that our x is an element of all real numbers. But if we look at our range, it's not the same for our range because we know the minimum value is going to be 0. Our graph doesn't go below 0. And so we can say that our y is equal to or greater than 0. And again, these are going to be also elements of real numbers, so we could include that in our range for our equation of x squared. Now, let's look at some other parameters that are going to influence what kind of shape our graph takes on. So these next three investigations are just going to help you explore what are called transformations. Now, a transformation, what that means is an operation which is going to move or map a figure from its original starting position to a new position. Okay, so if we had x squared, and that was our initial operation we were graphing, then that would be considered our original equation, right? But if we were to throw some variables into there, then there are going to be some changes to what that graph is going to look like and what that shape will take on. So here was our original graph. This was y equals x squared, or f of x is equal to x squared. When we have a graph that looks like this, just let me move this up a little bit, then we know that it's going to have a minimum point or vertex of coordinates 0 and 0. We also know that the minimum value of the function is going to be 0. But what's going to happen then if we write an equation which represents each of these following? F of x plus 3. So remember, f of x was x squared. So if we plug in x squared for f of x, we add 3 to that. And if we plug in f of x and subtract 3, what do you think is going to happen? Okay, so I just encourage you to pause the video here and just make a prediction of what you think is going to happen. And while you do that, I'm going to graph both of these functions. So my new function is x squared plus 3, and I also have x squared minus 3. X squared minus 3. Now when I graph both these equations, as you can see, I have my original graph on there, my original graph of x squared plus my two new ones. So I have one opening up at x squared, but it's moved up 3. And this other one, if I zoom out of here, or change my window settings to include that minimum point, I'm going to have a y minimum now. I think I'm going to say -6. So there's at 0. This one will be at +3, and this one will be at -3. So now the minimum value has moved down by 3 points. So what we graphed here was y is equal to x squared plus 3, and y is equal to x squared minus 3. And if we were to plot this on the graph here, that's the maximum point for this graph, and this is the minimum point for this graph down here. All right, and they're both going to follow the same rules in the case of how they open up. And it's going to look something like that, and this will look something like this. Okay, so you can see how it's following the exact same, like our parabola is taking on the same form, but it's transformed. It means it's moved up or down or sideways to a new location on our graph. And so this is what we just did. We used our graphing calculator to sketch the function f of x plus 3 and the function f of x minus 3 on our grid. Now the next thing we need to do is state what happened. Okay, so let's use this first one. So I have my original graph up there, and this was x squared plus 3. So this is the first function that we put up. So we're going to say y is equal to x squared plus 3. And if we look at where our vertex is, our vertex, remember, is our minimum point or maximum point, depending on whether our graph opens up or down. In this case, it's going to be a minimum point. Okay, so our minimum point here is going to be, instead of 0, 0, it's going to be at 0, 3. So that's going to be our new vertex. Our maximum or our minimum value is going to be, it's again a minimum value of +3. We know it's minimum because our graph is opening upwards. If it was opening downwards, then that would be our maximum value. Our axis of symmetry is going to stay the same. That's going to be x is equal to 0. And we know that too because if we were to cut this in half, the x value would be at 0 still. Now we've gone with this first equation, y equals x squared. There was no transformation because the graph just stayed the same. But in this new equation, x squared plus 3, we can see that there was a transformation. There was a vertical translation, which means it moved up. It moved up 3 units. So 3 units up. And that's all you have to put for your new function of x squared plus 3. Now let's look at x squared minus 3. Okay, so we know this is going to be, again, a minimum value of -3 this time. And so this was y is equal to x squared minus 3. We have a vertex of 0 and -3, and that vertex gives us a minimum value of -3. And our axis of symmetry is going to stay the same. And we're going to have a translation, but it's going to be a vertical translation this time. And that is going to be 3 units down. Good. So what if we were using this function? So for each of these, we're graphing these functions that are given. So now we're going to be using y is equal to f of x, which was x squared, plus q. So following this sort of logic here on our graph, we know that this is going to be at 0 and q. Just like this was at 0 and -3, this was 0, +3. This is going to be at 0 and q. This states that we have a minimum value. That's what each of these were actually saying, that there's a minimum value. So this time our minimum value is going to be at q. And we know that our equation for our axis of symmetry is going to remain the same at 0. And if we moved depending on the sign, so our positive or negative, that's going to also influence which direction we moved for having a variable in our equation. So this is just going to be, if we have a vertical translation of q units up. And again, in this case, q is just a variable, and that could be filled in by whatever q is actually equal to. So then what can we say is the effect of these parameters, q, on the graph of y is equal to x squared plus q? Well, what happens is there's going to be a vertical translation. All right, so it's vertical, meaning it goes up or down on the graph, and then it's going to go however many units up or down. In this case, since it's plus q, then that means it's going to be q units up. But if it was minus q, then that means it would be q units down. Okay, so compared to the graph of y is equal to x squared, the graph of y equals x squared plus q results in a vertical, remember verticals being up or down, a vertical translation or shift of q units depending on what q actually is. So if q is greater than 0, the parabola moves up. So if it's 1, 2, 3, or 4, then the parabola is going to move up 1, 2, or 3 units, or 4 units. If q is less than 0, the parabola moves down. Okay, so that should be pretty straightforward. All right, let's move on to what happens if we use our standard form of the equation, which is x minus p squared. All right, so up to this point, we've been looking at one equation, which is x squared, and then we've made some changes to that equation depending on different parameters. So those parameters being positive 3 or negative 3, or in some cases, just a variable of q. So now let's look at this graph that's given to us. It's x minus p squared. The graph of y equal to f of x, which is equal to x squared, is shown. All right, so you know that this is y equal to x squared. If we were to graph this in our calculators, which I have done here, it takes on the exact same form. Okay, and so one way you could think of this is if we put this in brackets and say that's x squared, it's going to take the exact same form. But what if we have x minus p squared, where p is a variable and p is going to be another type of translation? So in this case, let's look at y is equal to f of x plus 3. So we know that f of x is x squared, so we have to have this written as x plus 3 squared. And so here, I've written it as my equation of my line. And I'm going to do the same thing, but this time I'm going to include that variable, or this time it's a coefficient of 2, or of 3, sorry. And this first one was on negative 3, it was plus 3. So this would be a good time just to stop, pause, and just take an estimate or a guess of what's going to happen when you input this equation. And if you look at what happened when I graphed it, we actually had a horizontal translation, 3 units, it looks like, 1, 2, 3, to the left. So I had a positive 3, but that gave me 3 units to the left into an x is equal to negative 3. All right, so 1, 2, 3, that's what that looks like. And we follow the exact same points on our line. So I'll go up to 4 and up to 4 there again. And this is what this graph is going to look like. So I guess now you can take a wild guess as to what's going to look like when we have this function graphed. So I'm just going to change that to a negative sign, and it should pop up right there. There we go. There's our new point. Okay, so just take time to graph these, get used to graphing what these parabolas look like, and You are going to be doing this a lot in this unit. Okay, so what we did was we just graphed the equations x plus 3 squared and x minus 3 squared. Now with both those equations, using our equation of x squared as our original, we had two translations taking place, two transformations. And so let's fill in on the charts, on the tables here, what actually occurred. And so when we had y is equal to x plus 3 squared, our vertex now, remember, if we had our original vertex of x squared, then the vertex here is going to be 0, 0. And those are going to be coordinates on this graph. But now our coordinates are going to shift, and that's going to be positive 3, 0, if we're using x minus 3. But if we're using x plus 3, then there's our original graph. Our new graph is going to take the form negative 3 and 0. Okay, so our vertex is going to be a negative 3 and 0, and our minimum value is going to remain a minimum of 0, but our axis of symmetry is what changed. And now if we wanted to cut this graph in half, we'd have to draw a line right through x is equal to negative 3. So x is equal to negative 3. And now we had a horizontal. So when we had the variable of p, then we had a vertical translation. But now we have a horizontal translation, and this is going to be 3 units to the left. And so we know what x minus 3 looked like. Y is equal to x minus 3 squared. Right? And I'm just going to change this again, change that to a negative, and we had a vertical, or not a vertical translation this time, but we had a horizontal translation of 3 units to the right, which means our vertex is going to fall at 3 and 0, and our minimum value is going to remain at 0. It has to do with our y. But our axis of symmetry, instead of being negative 3, it's going to be positive 3. So again, that axis of symmetry is telling us that if we wanted to cut this new equation in half, that we would have to do so at x is equal to positive 3. All right, and so then we had a horizontal translation again, a horizontal translation 3 units to the right. Translation 3 units right. And so if we have x minus p, y is equal to x minus p squared, rather than graphing this, we don't have to, because we know that's going to follow this relationship. That's going to be p, that's what refers to p, and if it's negative, it actually means a positive on the x-axis. We're going to have a minimum value of 0, which corresponds to our y-axis, and this value of x actually is our equation of symmetry. So x is equal to p here, and again, we're just going to be horizontal translation p units. And in this case, it's going to be p units to the right. So, what is the effect of the parameter p on the graph of y is equal to x minus p squared? Well, that's going to be a horizontal, which means it goes either left or right along the horizon, a horizontal translation p units. P units. In this case, because we have a negative, that's going to be towards the right. Now compared to the graph of y is equal to x squared, the graph of y equals x minus p squared results in a horizontal translation. A horizontal translation or shift of p units. So if p is greater than 0, then the parabola is going to move towards the right. But if p is less than 0, the parabola moves towards the left. Now, let's just incorporate all these new ideas into some practice questions. So let's look at investigation number 3 here. So let's consider this function f of x is equal to x squared. Let's write an equation which represents f of x plus 2 minus 4. All right, so this is what the actual equation will look like. Y is equal to x plus 2 squared minus 4. And then we want to predict what the transformation on y is equal to x squared in A using a graphing calculator to verify our results. Okay, so what I'm going to predict is if I have, remember if we're using this form P and Q, then if we have a negative Q value like we do here, that's going to result in a translation 4 units down. Okay, so I'm going to say there's going to be a vertical translation 4 units down. But if we have a positive value, this means that there's going to be a translation to the left into -2. And so we're also going to have a horizontal translation 2 units to the left. 2 units, and I forgot to write units up there, but and that you really should. 2 units left. Okay? All right, so now we need to graph this on our calculators to see if we were actually right. And remember, we were graphing the equation y is equal to x plus 2 squared minus 4. Okay, so if we were using our original is just x squared. Our original graph is going to be this original parabola that we've been looking at this entire lesson. But we said that we wanted to go 4 units down, a vertical translation 4 units down. So that's 1, 2, 3, 4, which is good, and 2 units to the left. 1 and 2 units left. Perfect. So that's exactly the shape that our graph took. So our prediction was correct, which is great. So now let's fill in the information that we have. Y is equal to x plus 2 squared minus 4. Our vertex, remember where we want to find that lowest point? Our vertex is going to be at -2 and -4. -2 and -4. And these values you can get at looking at your graph. If it's positive inside the brackets, that means you'll have a negative value on your x-axis. And this doesn't change. If it's negative, then that's a negative value. If it's positive, it's a positive value. So that means that we have a minimum value of -4, and the equation of our line is that x is equal to -2. That's the equation of the axis of symmetry. And so we had a translation. That was a translation 2 units left and 4 units down. Now, let's see what's going to happen if we have this equation that we're graphing. Y is equal to x minus p squared plus q. Now, we're going to have these coordinates for our vertex, p and q. And we're going to have a minimum value that corresponds to our y value. So in this case, it's going to be q. And our axis of symmetry is going to be at x is equal to p. And if you are beginning to find out or find that relationship, then we're going to see that our translation is going to be p units. In this case, it's going to be right because it's going to make that value positive, and it's going to be q units down, or sorry, no, up, and q units up. Now we need to say how these graphs are going to follow the functions that relate to the graph y equals x squared. I'm not going to do all of them because I think these are things that you can most certainly do by yourself. But if we have our original graph y equals x squared, then if we add 10 inside the brackets, remember that corresponds to our x values, not our y values. So that's going to be a -10, which means that's going to be a translation to the left. Okay, so that's going to be 10 units left. If we have x squared plus 4, this is a vertical translation. This 4 is not inside the brackets, so that's going to be 4 units up. And yeah, this is more of a challenging one, but I'm gonna let you guys figure this out. If you have questions on this one, make sure you ask me this question in class. Okay, so this is class example number 1. Now let's work backwards from our equations. If we're still using the same. If we apply transformations to this graph of y equals x squared, we want to write the equations of the image function for each. If we have a horizontal translation of 5 units to the right, okay, so we have a horizontal translation, 5 units right. If we're using this original equation of x squared, then what did we have to do in order to make that translation move to the right? Remember that if it's moving horizontally, that has to do with our x values. Okay, so we know that something has to be in brackets. But if it's 5 units right, then that means if we were to draw a graph like this, then if our original parabola was right here, this new one is going to look something like this, where this is going to be its axis of symmetry at 0 and 0, and now it's going to be at 5 and 0. So that means that we have to have a -5 if it's moving in this direction. Remember, it's going to be opposite of that sign. Okay, so that's what our equation would look like. Let's look at the second one. Y is equal to a translation of 6 units down and 4 units left. Okay, so this time we're moving from here and we're going in this direction, and we're going 6 units down, so it's going to end up somewhere like this. Alright, and so if we're moving 4 units left, then that means that we have to go x plus 4, and 6 units down would be 6 units in the negative, -6. Now what I want you to do is I want you to work on this question, and I will give you some support with this question, this last one in class.